Welcome everyone to the AI Research Roundup. I'm your host Alex, and today we're diving into some fascinating AI research. We're looking at a paper called LLM Post-Training a Deep Dive into Reasoning Large Language Models. So, we know large language models are pre-trained on huge data sets, right? But this paper focuses on what happens after that, the post-training part. It explores how techniques like fine-tuning and reinforcement learning help refine these models, making them better at reasoning and aligning them with what users actually need. Essentially, it's a deep dive into optimizing LLMs beyond their initial training. So, building on that idea of post-training, Figure 1 here gives us a really nice visual breakdown. Think of it like a map of these techniques. Right at the center, you have LLM post-training, and branching out from there are the main approaches we just mentioned: fine-tuning, reinforcement learning, and test time scaling. Then, as you move outwards, you see more detail, like specific algorithms. Things like low-rank adaptation for tuning, RLHF for reinforcement, and chain of thought for scaling. And finally, the outer ring shows which actual models like GPT-4 or Llama 3 use these different methods. It really lays out the whole landscape. Okay, so Figure 2 zooms in a bit further, especially on the reasoning side of things. Building on that first diagram, this one shows specific inference time reasoning methods on the left. Things like chain of thought prompting, which we mentioned, but also tree of thoughts and self-feedback. And then, well, on the right, it unpacks those reinforcement learning techniques like RLHF and DPO into more detailed process flows. You can see the actual steps involved, like training reward models or using preference pairs, leading to those final optimized policies. It gives a clearer picture of how these RL methods refine reasoning. So moving on from the specific reasoning and RL techniques, Figure 4 gives us a slightly different perspective, focusing more on efficiency during fine-tuning and deployment. It's a Venn diagram showing how system, data, and model all interact. We see things like hardware accelerators and distributed training under system, data compression and filtering under data, and model compression or co-optimized architectures under model. It really highlights the practical strategies needed to make these post-training methods work efficiently at scale. So Figure 5 shifts our focus a bit more towards what happens right at inference or test time. Remember back in Figure 1, test time scaling was one of those main post-training branches? Well, this figure unpacks that. We see some familiar reasoning techniques like chain of thought and tree of thoughts again, but placed specifically in this test time context. What's new here are categories like scaling strategies, using things like beam search or best of n search, advanced sampling, and also sequential revision techniques. It really details the methods used to boost performance as the model is generating output without further training. So now Figure 7 takes a broader view again, but specifically focuses on the research trends within reinforcement learning post-training over the last few years. Unlike the previous figures that mapped out techniques, this one shows us how much research is happening in different RL areas year by year. We see trends for advanced RL, reward modeling, decoding strategies, which we've touched on, but also safety, personalization, and even process versus outcome-based rewards. It gives a sense of where the research community's focus has been growing or shifting within RL for LLMs. So, seeing those trends in Figure 7 really underscores how active this post-training space is. What this paper provides is a fantastic, comprehensive map of all the techniques being developed to really enhance large language models after their initial pre-training. It's clear that improving reasoning and performance isn't just about basic fine-tuning anymore. This research is absolutely critical for building more capable, reliable, and efficient AI systems going forward. Well, that wraps up our look at this deep dive. Thanks for joining me on the AI Research Roundup. I'm your host, Alex.